Solving radical equations. In solving radical equations, our first step is to get the radical expression by itself. Once we have that, we want to raise both sides of the equation to an appropriate power that's going to undo the radical. For example, if it's a square root, we would square both sides of the equation. If it's a fifth root, we would raise both sides of the equation to the fifth power. Then we'll want to solve the resulting equation, and then we have to be sure on these to check our answers. Sometimes we'll get answers that will not work when we go back to our original equation. So let's try some. Here we have the square root of 3x plus 5 equals 6. Now here the radical term is by itself. So we begin this problem by undoing the radical. That is, we want to square both sides of our equation. So squaring the square root will just give us the 3x plus 5. And squaring the 6 will give us 36. So this becomes a pretty simple equation to solve. We subtract 5 from both sides to get 3x equals 31, and then divide by 3. So that gives us x equals 31 thirds. Now we have to check it, because sometimes, especially when we square both sides of the equation, we can end up with funny things happening with our signs. So I'm going to go back to the original problem and plug this in. So under the radical, I have 3 times 31 over 3 plus 5. So when I work this out under the radical, the 3 and the 3 in the denominator will cancel. So on the left side of the equation, I have the square root of 31 plus 5, which of course is the square root of 36, which gives me 6. And that does equal the number on the other side of the equation. So it works. Let's look at this problem. This involves a cube root. Okay. Our first step, again, is to isolate the radical. It was already by itself over here, but here, in order to isolate the radical, or get that cube root by itself, we have to subtract 6 from both sides. So that's going to give us the cube root of 2x equals 12. Now, in order to undo the root, we have to cube both sides. To undo a cube root, you would cube both sides. So cubing the cube root will give us our 2x. Then on the other side, we're going to have 12 cubed. Let me go to my calculator and see what that is. 12 raised to the third power is 1,728. Now all I have to do is divide by 2. So I'll get x equals 864. So then I would check it. I would have the cube root of 2 times 864 plus 6 equals 18. I want to see if this really does equal 18. So the 2 times the 864 is the cube root of 1728. And the cube root of 1728 is 12. So I have 12 plus 6, which is 18. So the answer checks. Now, let's look at this problem. Here, my radical is not by itself. In order to get it by itself, I have to add x to both sides. So this is going to give me the square root of 9x plus 81 equals x plus 5. Now, I still need to undo the radical. Since it's a square root, I square both sides of the equation. Squaring the square root will just give me the 9x plus 81. But when I square x plus 5, remember that really means x plus 5 times x plus 5. So when you multiply that out, it gives you x squared plus 10x plus 25. If you don't remember the formula for that, you can multiply it out using FOIL. So now I'm left with a quadratic equation to solve. So in order to solve this, I need to get it in standard form, which means I need to subtract my 9x and subtract my 81 from both sides of my equation. So that's going to give me 0 equals x squared plus 1x, or just plus x, minus, let's see, 25 minus 81 is going to give me minus 56. Now I solve this. This I can solve by factoring. Typically, it's better to solve by factoring if it is an equation that will factor. This will factor into x minus, x minus 7 times x plus 8. Because we want numbers that multiply together to give us negative 56 and add together to give us positive 1. So then I set each factor equal to 0, and that gives me an x equals 7 and an x equals negative 8. Now, I have to check both of these. I'll give myself a little bit more room here. To check both of these, I have to do them one at a time. So let me check the x equals 7 first. I'm going to plug that in. That'll give me 9 times 7 plus 81 minus 7 equals 5. This is what I want to see, if this side really equals 5. So my 9 times 7 will be a 63. So I have 63 plus 81 under the radical. 63 plus 81 gives me 144. So I have square root of 144 minus 7, which is 12 minus 7, which is 5. So my 7 works. Now let me try the x equals negative 8. If I plug this in, I don't have to go very far to see what's going to happen here. When I work this out under the radical, I get the square root of a, let's see, negative 72 plus 81. Negative 72 plus 81. It's going to give me a 9. So here I have the square root of 9 minus 7 is 3 minus 7. But 3 minus 7 gives me a negative answer under here. It gives me a negative 4, not under here, but on this side of the equation. And remember that on the other side of the equation, I had a 5. So negative 4 equals 5 is not a true statement. So my negative 8 I have to throw out. I have one more to look at here. Oh wait, I forgot one on that page. I forgot the one on my last page. Let me go back to it. X to the 2/3 power equals 8. Remember that this 2/3, the 3 in the denominator really means it's like a cube root. So to undo a cube root, you would cube both sides of the equation. So that's what I'm going to do. I would have x squared. When I cube this, the 3's cancel, leaving me with x squared. equals 8 cubed, which is 512. So x is going to be the positive or negative square root of 512, because I'll solve that by taking my square roots. So my square root of 512, it's not a perfect square, so I do need to simplify this. Let's think of what perfect squares would go into 512. I know that 4 will go into it, but I think maybe 16. Oh, I might can even go larger than that. Let's see if 36, not 36. Oops. If I use my 16, that would give me a square root of 16 times the square root of 32. But this 32 still has a factor in it that's a perfect square. So let's see if I can go bigger. Let's see if 64. 64 would go into it. That would give me a 64 times an 8, but I could still reduce that some more. This would give me, plus or minus 8 times the square root of 8. But 8 times the square root of 8, oh, I'm running out of room. It's going to be 8 times the square root of 4 times the square root of 2. So I have 8 times 2 times the square root of 2, which is 16 square roots of 2. Now, this, actually both answers will work because we were dealing with a cube root. Okay, now I have one more equation to show you. Here we have 2 radicals and an extra term. So probably what's easiest here is to isolate one of the radicals. So let me write this as the square root of y minus 9 equals 9 minus the square root of y. And then square both sides. And this problem gets a little messy because there's quite a bit of algebra to do. Squaring the square root will give you the y minus 9. But here, this is going to be 9 minus the square root of y times 9 minus the square root of y. We can't just square each term. You know, this is really a FOIL process here. When I do that multiplication, that's going to give me 81 minus 18 square roots of y plus the square root of y times the square root of y will be just a y. Now, I have one radical still in my equation, so I want to get that by itself. So I'm going to subtract my 81, and I'm going to subtract my y. So I'll subtract the y and subtract the 81 over here. So the y's cancel, negative 9 and a negative 81 will give me a negative 90. So I have negative 90 equals negative 18 times the square root of y. Now, I can divide by the negative 18 to get that square root of y by itself. Sometimes this will come out a nice number. Sometimes you'll need to just reduce the fraction. This comes out to a whole number though. 5 equals the square root of y. So now when you square both sides, you get 25 is equal to y. And I won't take the time to go through and check it, but if you plug it back in, it does in fact check.